The first version is always repeated. So I think that's my point. So yeah.
Welcome back and good morning. You guys should have put your homeworks in the basket this morning. Go over it in class. Okay. You have no more time to do the videos in class. Because I'm gonna try to catch up on the days that I left the house. Roman numerals. Yes, we still use Roman numerals in the practice of pharmacy and medicine. And where do you see them, or where can you see them? In practice, you can still see them on prescriptions. Okay, either the number or the quantity to be dispensed is in Roman numerals, okay, or the sig is in Roman numerals. Okay, what are the most common Roman numerals that we use in the practice of medicine and pharmacy? V. V. Right off the bat. Okay, let's start. It's okay. I was just surprised to get a V, not an I.
Obviously, but
It's okay. Okay. Let me see my black. V. So I'm gonna put the V here. Okay. I V. What's next? X. You guys are all over the place. I'm trying to go do it in order. Okay. I V X. What's X? L. C. D. Okay. Let's do the equivalents first. Okay. I is equivalent to BS, XS, LS, CS, DS, MS. We also use another symbol which is equivalent to half. SS lowercase, not capital. Okay, it means half or 0.5. A couple of things I'd like you to know so that you remember this Roman numerals. Okay, first, C. C, the way I remember it, century. There's 100 years in a century. Another one is M. Millennium. There's 1,000 years in a millennium. Okay, those two. That's how I remember it. Okay. There was a period wherein I was wondering, and I told you this story, maybe it's a repeat for many of you. I said, how did the students get this wrong, the L wrong? And one of the students, Gina, told me, Miss L, this time you didn't mention that you're on your road to 50. Miss L is on her road to 50, my next milestone. Okay. And so I said, is that why? I said, I'm trying not to say that anymore. But Gina, one of the students said, yeah, Miss L, this is the first time you didn't say that Miss L is on her road to 50. And so I said, I don't understand why the L's are wrong. So I'm mentioning L is 50. Back in the day, one of the instructors always say, oh, LV is 55, Las Vegas is 55 years old. Not anymore. We're older than that. Las Vegas is older than that. So 1 is I, V is 5, X is 10, L is 50, C is 100, D is 500, M is 1,000, and SS is half. SS came from the Latin word semis. Semi, not even a full, semis. Okay, so it's half. Some rules on Roman numerals. Okay, one, you're going to see them as a quantity, a total quantity. Okay, and sometimes you will see them in symbols like ounce or fluid dram, or ounce or dram, okay? Or even GR, grains, okay? You know how when we write number before the units first, when you see the symbols, the Roman numerals are after the unit. It's in reverse, okay? All right. So let's talk about the rules. This Roman numerals, sometimes, usually, it has to be capital letters. Okay, but sometimes doctors use lowercase for the I and the X. Okay, and I want you to be familiar with that. But what are the rules? You can repeat some of these Roman numerals a maximum of 3 times. And which ones are these that you can repeat up to 3 times? I, so we can write. So we can do this a maximum of 3, and it looks like this, right? Okay, but like I said, some doctors use lowercase. So you will see I, or 2, or 3. But most of the time, instead of that, we do this. Doctors do this. And it means 1, 2, and 3 tablets or capsules. Is that clear? Okay. V, capital or lowercase v, which is hard to tell, right? Can this be repeated? No. So we can repeat I. Can we repeat X? Yes. So a maximum of 3 times. That means this one's equivalent to 30, or it can be this way. Okay. Can we repeat L? No. Can we repeat C?
Yes.
Yes. So maximum of 3 times. So this is equivalent to 300. Okay. Can we repeat D?
No.
Can we repeat M?
Yes.
Yes. Okay. So this can be M, which is equivalent to 3,000. Okay. First rule. True. The Roman numeral should be in what order? Highest to lowest value, lowest to highest value. Highest to lowest value. Okay. So we just add them if they're highest to lowest value. Okay. But there are Roman numerals that we can use to subtract. Okay. What am I talking about? Let's put it in an example. So VI, what's V? 5. And then what's I? Is this in highest to lowest value? We just add 6. Correct? When it becomes IV, this is 1 and this is 5. What do we do here? Subtract, or this carries a minus sign, and this should give you. Follow? Let's do another one. What's XI? X is 10. I is 1. Is it in higher to lower value?
Yes.
So this will be 11. What if it becomes IX? 1 and 10, this carries a negative sign, so this is equivalent to? My fellow Americans, when is the Declaration of Independence? Oh my God. And every sequence. Thank you. Okay. My MMA coach yesterday was wearing a shirt with an American flag, and this was in there. And they kind of smiled. Okay. Because I always ask this in class. Okay. So 1776. Let's treat it as a number, 1776. If I'm to write this in Roman numerals, what would it be? M, D, C, C, L, X, V, I. Okay, I'm following what you're saying. Now let's double check and add. This one is 1,000. This is 500, 100, 100. There goes your 1,700, right? This one is a 50. This one is a 10, and this one is a 10. There goes your 70, right? And this is your 5, and this is your 1. There's your 1776. I always tell this story. Where can you see it? Statue of Liberty. I had a smart ass student and said, Michelle, we're gonna go to New York to look it up, like to look at it. No, just go to Trump and Las Vegas Boulevard. Yeah. It's got this in Roman numerals, just holding it. Okay, so let's do your in-class work that was assigned to you ahead of time. Any questions on this one? It's very common to see these ones tied to this units. Remember, instead of number and units first, when it's Roman numerals, it's units first before the numbers. Put it in practice. Roman numerals, and then we'll probably stop before moving forward if there are other rules that we'll encounter. In classwork starts with XXIV, correct?
Yes.
Okay, let's start at the back. Antonio. XXIV is? 24. Number 2, Erin. 4. Number 3, Maria. 19. 4, Michelle. 110. 5, Zoe. Who got the first 5 correct? Hands up. Good job. It's everybody, okay? Number 6, Emily. 30. Number 7, Brian. You're still finding it?
I got it. 16.
Correct. Number 8, Alex. Number 9, Lizette.
14.
Number 20, Poirier. Correct. Who got the next 5 correct? 6 to 10. Okay, moving on. Leslie. L is 50. 12, Carla. LX. 13, Cheyenne. Correct. 14, Daya. Correct. Who got 11 to 14? Correct. Okay, everyone. 15. Good job. 16, Maria. Again. Okay, it's 3 X's. Okay, XXX, VI. So it's 36. Good job. 17, Emily. XCII. Correct. Number 18, Aaron. VLX. Number 19, Zoe. Yeah.
UCLX.
Correct. Number 20, Carla.
MCMXCIII.
Good job. Who got everything correct? Hands up. Okay. Any questions on Roman numerals? Moving on. Okay. Now we start household to metric. Okay. Household to metric conversion of weights. Okay. Weights. After weights, we got height. Okay. So weight and height. So kilograms to pounds, pounds to kilograms, and centimeters to inches, inches to centimeters. Okay. So these 2 topics that I'm going to be going over. These 2 topics that I'm going to be going over is important in dosage calculation. What particular one? Pediatric dosing. Not only pediatric, can be used for adults too. But why is it important? The height and the weight. Correct. Because the height and weight are the 2 variables used in body surface area. Okay. Which is used for calculating the dosage or amount of drug that we need to give to the patients, pediatric or adult. Okay. Next topic will be household to metric conversion of weight. Okay. Kilograms to pounds, pounds to kilograms. Which one is what we use in the US? Pounds. That means that's our household. Okay. Kilograms is the metric. So whatever we use in our houses, that's household. Okay. But in other countries, to this day, like my friends and I talk, they tell their weight in kilograms, and I have to calculate in my head. Okay. Like go to the market or the groceries, it's per kilo. Here it's per pound, right? Okay, so kilograms to pounds. What's our conversion factor? 1 kilogram is 2.2 pounds. Okay, pounds. Oh, why is that pounds? LBS came from the word libras. Who's a Libra? Sign. No one. Okay, but you know the symbol for Libra? That's the weighing scale. Yes, because yes, right there. Okay, libras. 1 kilogram is equal to 2.2 pounds. Can't be flip flop. When I teach conversions, there's only 2 ways I want you to do. Well, back in the day, I teach it 6 different ways. And I was hoping one of those 6 ways the students know. Okay. But I realized through the years, it just confused them. So I limited it to 2. Okay. There's something I'd like you to stop doing: multiplying or dividing. Okay. It's a very common mistake through the years that I've seen students do. They multiply when they have to divide and divide when they have to multiply. Common mistake. Okay. No matter how good the student is. Okay. And we cannot risk our patients by doing that. Okay. So what happens when you multiply in the process when you're supposed to divide? You get more. So that's what you call an overdose. What happens when you divide when you should have multiplied? Underdose. You're probably thinking, oh, underdose is better than overdose. No, not always the case. Okay. Why? Example would be antibiotic. Okay. So underdose is just as bad as overdose. So don't say, oh, I did it the other way anyway. No. Okay. So I beg of you to stop multiplying and dividing. There are 2 ways I'd like you to do. Okay. Ratio, proportion, or dimensional analysis. Okay. Either one of the 2. And how do we do that? So if it's ratio proportion, say for example, 135 pounds, be careful. This is not 1, but when you're given a test paper, sometimes this looks like a 1 because of the font, okay? Some students did that. There's no unit in pharmacy that's called BS. You may BS your instructions, but you cannot BS me. There's no unit BS. Okay, so it's always LBS. 135 pounds to kilograms. How do we do with that ratio and proportion? You always go back to your conversion factor. And what is that? How is it done? A kilogram is 2.2 pounds. As to, what do I put on top? XKG is to 135 pounds. I know it's work, but by setting it up this way, you validate that you have to multiply or you have to divide. And you're not risking the patient's life. It's going to be more dangerous once we get to kilograms to grams, grams to milligrams, milligrams to micrograms, because that's when it becomes 1,000 times overdose or underdose. Okay, and this is sequence 1. You are going to research on those cases of babies that died. One of them is because the baby was given milligrams of zinc instead of micrograms. Of course, to that. Okay. And so limited it to 2. This is your ratio and proportion. Okay, I'll repeat it. One of my favorite professors said there's not a single problem in pharmacy that you cannot solve using ratio and proportion. And to this day, I can't prove her wrong, that I want to. Okay, so this just validated that you have to divide because this is a 1, right? Answer is 61.364 kilograms. 61 point? What's my rule? Verbal order. Keep everything 2 decimal places or the hundredths place except for temperature. That's my verbal order. You didn't get any instructions, so my verbal order stays. Okay? 61.36. And what will this be? Kilograms. Okay? That's your answer. Dimensional analysis. Who did dimensional analysis? Chemistry. Michelle likes dimensional analysis. How do we solve this? Most of your pharmacists will do dimensional analysis. I told you, the only reason I shifted to ratio and proportion was when I started teaching. Because the students understood ratio and proportion better than dimensional analysis, okay? But dimensional analysis always comes in very handy, especially in word problems. So how do we do this dimensional analysis? 135 pounds, instead of equals, ratio and proportion is equals. Dimensional analysis is times. It's pounds, so I'm going to put my pounds unit here right off the bat. So I could cancel one from the numerator and one from the denominator. Am I given a pounds? Yes, 135 pounds, right? So this will be what? X kilograms, correct? And the rule of multiplication is there's an invisible one over here. Multiply all numerators, multiply all denominators before you proceed. Okay? Oh, I'm sorry. I put something in here. So 135 pounds, what's my conversion factor? 1 kilogram is 2.2 pounds. Okay, now I can cancel the pounds unit. You see that? Now I just validated again that I have to divide. And what will my answer be here? 61.36 kilograms. You have to remember the ratio and proportion is equals at the middle. Dimensional analysis is times. So you have to follow the rule of multiplying and dividing fractions, okay? But if you see, I set it up so that the pounds is at the bottom. I can cancel the symbol or the unit, okay? And then I'm given with kilograms. Any question on this one? Okay, stick to dimensional analysis or ratio and proportion. I don't want you to see, I don't want anybody doing multiplying and dividing, okay? So let's do some in-class work. Do we measure the weight of the patient? No, it's not our job, okay? It's not our job, but this is necessary in what? Calculating for body surface area, which is used in calculating the correct dose or amount of drug that we need to give to the patient, okay? So some in-class work.
So, you know,